we have already learned the basic ideas of work and energy, right? So for example, we know that if I exert a force on an object, I am transferring energy and that process is called work. So when I'm giving it work, actually what I'm doing, I'm giving it energy, right? So for example, you know that the net work done on a body by all forces acting on it is the change in kinetic energy. We have already learned this. Now let us take this case. So if I take this ball and let us say I'm applying 10 newtons force on it, so I'm pushing it. So when I push it through 2 meters, right, what is going to happen to this ball? It's going to get a velocity. Like for example, if I push it like this and I leave it, you saw that it gets a velocity, right? It has a kinetic energy. So it starts, let us say, with 0 meters per second. It will end up with a kinetic energy. How much will be the kinetic energy? Half mv square, but how much will it be? It will be equal to the energy that I supplied, and the energy that I supplied will be F into S, same direction. So therefore, the kinetic energy final is going to be 10 into 2, 20 joules. If you want, you can calculate that in terms of the velocity. You can use that to find the velocity, okay? So it has a velocity, but I want you to keep in mind that the kinetic energy is 20 joules. So whatever work I have done hasn't got lost, it has got stored as the kinetic energy of the object. So that we know. But let us take another example. So if I take this example, let us say I have a surface like this, and I take this block, same mass, let's say, and I'm pushing this block. I'm pushing it, and you can see I have moved it, let us say, by 2 meters. Obviously here it's much less than 2, but you get the idea. So let me show it again. So I'm pushing it and I'm moving it by 2 meters. How much work have I done? 10 into 2, 20. I have still done 20 joules, exactly like that. What is the kinetic energy of this object? 0. You can see it's not moving. Hey, what happened to the energy that I gave? Because I gave how much? I gave, so the first case, work done by me is how much? 20 joules. Kinetic energy of the object is how much? 20 joules. So this went there. Second case, work done by me is 20 joules. Kinetic energy of the object, 0. And only interested in final kinetic energy. So initially we will say they are all starting at rest. But this guy finally is also at rest. So final kinetic energy is 0. But I gave so much energy. What happened to it? Well, because friction ate it up. Friction stole my energy. Because we are talking about a situation where the object moves very slowly. Look at this. It's moving very slowly. So what is its acceleration? 0. Okay, a very tiny velocity. So if acceleration is 0, it is not speeding up. That means the force that I put in and the force that friction gives together must be 0, because net force must be 0, acceleration is 0. So whatever work I did, I was exerting a force like that, so, and it went forward, so that means I did positive work. Friction force was like that, and friction force is like this, displacement is like this, work is negative. So friction took away energy. So what is the work done by friction? 10 to opposite direction, so minus 20 joules. 10 into 2 minus 20 joules. So can you see that this energy did not go to kinetic energy? It went to friction eating up the energy. We know that the total work done by all forces must be the change in kinetic energy. What is the work done by me? 20. Work done by friction? Minus 20. Total work done? 0. So kinetic energy beginning was 0. Kinetic energy in the end is 0. Now you may say, how can it move if it was 0? It is moving very, very slowly. Imagine that we are doing this extremely slowly. It really doesn't matter. This could have started at 5 meters per second and ended at 5 meters per second. We would have said the change in kinetic energy is 0. What matters is not the final. What matters is the change. Since initially is 0, final is 0, change is 0. If initial was 5 meters per second, so that means some kinetic energy. End was also 5 meters per second, same kinetic energy. So change in kinetic energy would have still been 0. But I'm going to start with 0 and do it at 0, so that's easier to understand. So I hope this is clear. Work done by me lost to friction. So we will say friction stole the energy that I supplied. My work or energy that should have gone to the object. Okay, energy supplied was stolen by friction. Why do I say stolen by friction? Because after I do this, friction took it away. Now you say give it back, it's not going to come back, it is not going to speed up. That energy is lost. It is not really lost because nothing is lost in this universe in that sense. So the energy is taken by friction and distributed out to lots of small tiny molecules. But that's not going to come back to our object. So that means the energy that I gave was really in some sense lost. Now let us take this other example. Exactly like this, where I was pushing, except now I'm going to push it upwards. So I'm exerting a force upwards and this ball is moving upwards. By how much? By 2 meters. How much force am I exerting? 10 newtons, and I'm doing this very slowly. How am I able to do it very slowly? This must have been a mass of 1 kg. So gravitational force, it has a gravitational force of mg, which is 10 newtons. Okay, so this is 10 newtons. And when I'm taking it up like that, am I doing work? Yes. How much work am I doing? Work by me. 10 into 2, so that means it is 20 joules. Right? I am basically lifting it up, so it is 20 joules. What is the kinetic energy of the object there? 0. So here kinetic energy final 0. What is the kinetic energy initial? 0. What is the change in kinetic energy? 0. Okay, but I did work. There is no friction in this case for friction to steal. So who stole the energy? Gravity stole the energy. Work done by gravity. How much is the work done by gravity? Gravity is pulling it down 10, but you are going up 2. So work done by gravity is 10 into 2 into minus 1, cos of 180 degrees, because it's like this angle between them, right? So gravity has done work of minus 20 joules. So total work done, net work done, 0. That's why the fellow did not get kinetic energy. Kinetic energy is 0. So what should I say about gravity? I should say gravity stole my work. So I should say gravity stole my work or my energy supply. Same thing. Work is actually energy supply. Okay. So gravity stole it. But then gravity comes and says, no, stop. I did not steal anything. I have only taken it and I've kept it safely. If I let go, gravity returns it back. See, if I lift it up, I supplied energy, and if I leave it, what happens? You will get back the energy. So in fact, if this fellow had some velocity v, that means some kinetic energy, let us say some amount, let us say 5 joules. When I throw it up, the ball goes up. At that point, what is the kinetic energy? 0. But then ball doesn't stay there forever. The ball comes back. When it comes back, gravity gives back that energy. So when it comes back here, it comes back with 5 joules. That means, did gravity really steal the energy? No, it is going to return it. So you can either say gravity borrowed the energy, or more importantly, you can say gravity stored the energy. So gravity is arguing that it is not stole, it is stored. So gravitation is like a bank. So let us say I have 1000 rupees. So the 1000 rupees right now with me, so I can spend it. I go to a bank and then I go and give that money to the bank. Now we are not talking about Indian banks, okay? Sometimes many of them just you go give it, then that's the end of the money. So we are talking about good banks. So if I go to a good bank and then I give that money, hopefully they will put it in my name, in my account. I have actually given the money to them. They have taken the money. So if you ask, when I gave 1000 rupees, how much did they give me? You will say minus 1000. They didn't give you anything. They took away the energy. They took away the money. But they didn't take it away and then spend it somewhere else. They're not like friction, hopefully. They are supposed to return it back to you, which means they are storing your money in the bank. So think of potential energy, which is what we're going to use. The term potential energy is like a bank. Gravity is like a bank. It is saying, whatever work you have done, I have kept it for this fellow for tomorrow. Tomorrow when this fellow comes back down, the same energy that you gave will be returned back. It is stored and is returnable. It is returnable energy. So what gravity is doing is it's taking that minus 20. So that means it's taking 20. I am giving 20 to the ball. Right? Gravity is taking the 20 away. But it's not taking it away and losing it. It's taking away and storing it. Okay? So instead of saying gravity stole, we will say gravity stored it in the form of potential energy. Now any such thing, any force which can do this, we call such a force which can store and not lose it. We call such a force conservative force. Conservative forces. Spring is an example of a conservative force. So if I take this spring and I pull the spring, I did work in pulling it because I'm exerting a force like that, but no kinetic energy. But if I do that, you see that it jumps back. So it has stored, it's not lost the energy, stored it, and it's going to return it back whenever you want it. Right? Gravity has stored it and is going to return it whenever you want it. Friction steals it and can't return. So we call friction non-conservative force. Okay? So whenever a force is conservative, it is not stealing the energy, it is storing the energy. And the way it stores it, we call it potential energy. Mostly people use potential energy to mean gravitational potential energy, but there is spring potential energy, there is electric potential energy. Any way in which you can store the energy and return it later, it is called potential energy. So in principle, we should be calling it GPE, gravitational potential energy, spring potential energy. But instead of doing that, what I'm going to do is I'll just call this PE. So what does PE mean? Gravitational potential energy. Then what do I do for spring energy? I'll call it SC, spring energy. But the technical way to write it is gravitational potential energy, spring potential energy. So I hope that is clear. So first point, gravity did work, negative work, it took it away. And this minus 20 is stored, it takes the energy and then it's keeping it there. So how much has been stored? So bank, how much money did, when you go and deposit 1,000 rupees, how much money did the bank give you? It didn't give you anything, it actually took. So you'll say it gave me minus 1,000. I went to the bank and bank gave me minus 1,000. Of course, we don't say that language, right? We go there and we say, I gave the bank 1,000 rupees. But if you wanted to do mathematically, it is the same thing as saying bank gave me minus 1,000 rupees. But when bank gives me minus 1,000 rupees, it's actually taking 1,000 and storing 1,000. Now I want to know how much has it stored. It has stored 20 joules. You can do this in two ways. You can say the work I did, which is 20 joules, instead of going into kinetic energy, has gone into potential energy. Gravity has not even come into the picture. Instead of going into kinetic energy, see here, whatever work I did went into kinetic energy. Here, whatever work I did has not gone into kinetic energy, has gone into potential energy. This is one way of doing the problem. Another way is to say, I did work, gravity stole. So gravity also did work. How much work? Minus 20. That means it stole. But it didn't steal, it stored. So it took that 20 and then it stored it as 20 joules. You understand the difference? So we will use both ways of expressing. So let me show you with a little bit more formal way of how to write this when we are actually doing the calculation. So let us now look at this situation. I have a ball of mass m. I am lifting it up such that its kinetic energy is not changing. So whatever kinetic energy they had in the beginning, it remains constant throughout, let's say. It could be zero. It could be zero. It could have been moving very slowly, but that's not a requirement. It could have been half m into 4 square, half m into 4 square. Speed could have been maintained at 4. It can even change direction. That doesn't matter. Speed must remain the same. So if the kinetic energy remains the same, what is delta Ke? 0. Well, if delta K is 0, work done by all forces must be 0. There are only two forces. So, work done by external force, which means not gravity, not the block's own force. You're talking about a force like my force. My force is external to the block or to the ball. Work done by the external force plus work done by gravity is equal to 0. So work done by gravity is minus of the work done by the external force. How much is the external force? Well, if it has to move without any acceleration, external force must also be equal to mg. Correct? Because acceleration is 0. It's moving very slowly or it is moving with constant velocity, which means 0 acceleration. So then what is the work done by the external force? Mg into h. By the way, if this ball went like this, also it will be mg into h. That I am not arguing or discussing it right now, but you can see that it will be mg into h. Work done by gravity, mg is this way, h is that way. So work done by gravity is minus, this is plus mg into h, that is minus mg into h. So one way to argue this entire thing out is to say work done by external force is eaten up by gravity and then stored. The other way is to say ignore the gravity. How much work did I do? Mg into h. Gravity did not steal it, but it has stored it in the form of potential energy. So if the original potential energy was x, now there is an extra potential energy of mg into h. This is the work that I did. I gave it energy. So whatever energy it had, x, has now become mgh plus x. What is x? We don't know. But it is very convenient to select some place where x is 0. So suppose I chose this and called it 0 level, which means x is 0. Then I don't need to worry about the x there. So there I will say the potential energy is mgh. So what does this tell us? This tells us whatever work I did has not got lost, it has got stored. Instead of going in as kinetic energy, it has got stored as potential energy. If I throw a ball like this, I exert a force F and it moves through a displacement, let us say S. The kinetic energy, let's say here the kinetic energy was 0, here kinetic energy final will be equal to the energy that I supplied, which is F external into S, which is work external. So what has become work external? Kinetic energy. Here, what has become the work external? Like work has been done, right? Mg into h. What has become that? Potential energy. So what is the formula in some sense for potential energy? mgh. Let us try to understand this a little bit more. You cannot use this and this together in one problem. That is like double counting. You can either say gravity stole it, gravity took away, gravity has taken and stored it, all that is fine. That means you are using work done by gravity. Or you can say, forget gravity, whatever energy I gave, who says it's lost? Instead of going as kinetic energy, it has gone as potential energy. Two ways of thinking about it. One is to say, whatever work I am doing has gone into another form of energy called potential energy. By the way, that is usually a better way of thinking. Okay. Now, this same statement that we have, if the second one was gravity, you can take this to that side. It will become minus work done by gravity because it's plus. When you take it to that side of an equation, what happens? It becomes minus. So when it becomes minus, it becomes potential energy. So potential energy or change in potential energy is minus work done by gravity. Because you see, gravity does negative work, but it's not really negative in the sense that it's doing negative work on the object, it's taking. like the bank takes money from you. So this fellow takes the work from or energy from the object, and then it's going to store. So what was the work done by gravity? Already negative, so minus of it will become positive. That is the amount of energy stored in the system. We say that the gravitational potential energy is not stored in the object, but stored in the gravitational system. So this is the change in the energy. Okay. Another way is to say this is also equal to work done by the external force. No minus here, it is a plus. Because whatever I am doing is what is getting stored there. So you can either do it as a two-step process. I do work, gravity takes it, then gravity stores it. That is one way. But why will you go through such a long way? Whatever work I have done is directly got stored as potential energy. So that is a better way to think and use. Okay. So we will keep using this a lot. It's not just true for gravity, it's true for all sorts of conservative forces. So work done by the external force, there is a small set of things that you should keep in mind. This work must be done in such a way that kinetic energy does not change. Simplest is to say, move it very slowly. If it's very slowly, here also kinetic energy is zero, there also kinetic energy is zero. So work done by an external force in very slowly moving the object, work done by the external force in very slowly moving the object is equal to the potential energy stored at the end. Clear? Or you can say minus of the work done by the gravitational force or that conservative force, any conservative force. So you can either use the minus sign for that force, or you can use the plus sign for an external force. But with external force, you should be careful that it was done in such a way that no kinetic energy change happened. Okay, that is about a broad thing. Now let us come back to potential energy. The formula you can know is mgh. There are two very important things to keep in mind. When you say mgh, m is a positive quantity, g is always a positive quantity. Whether you're going up or down, g is a positive quantity. G is just simply 9.8 or 10 meters per second square. H is not height. H is actually height above. We should have called it y, like in y coordinate. So you have to define a zero level like I defined. So if this is my zero level and you have an object sitting there, potential energy is m into g into, let us say this was plus 3 meters. 3 meters, let me just call it 3 meters. This into plus 3. Why? Because it is h above the zero level. This is the zero level. Okay. But if I had this object 3 meters down below the zero level, then potential energy here should be m into g into minus 3. So when you're going below the zero level, potential energy is negative. How can energy be negative? Absolutely no problem. It can be. It's a wrong idea that potential energy or energy cannot be negative. What matters is actually change in energy. Remember I called this x, it was mg plus x. Then I suddenly call this 0 because I have the right to choose some place as being 0. So once I set this as 0, that becomes mgh. Because you are h above. If you went h below, it would have been mg into minus h. Okay, so this mgh is the formula, but h comes with a sign. Height above the zero level, height below the zero level. Second, always select the zero level. Because you can't talk, always select the zero level. Before you start talking about potential energy, you must select the zero level. Where should you select the zero level? Ground? Not necessary, anywhere you want. First floor, if suppose I was doing this experiment in the first floor, then I'm going to say first floor ground is basically my zero level. Somebody else will say no, ground floor is zero level. Somebody else will say third floor is zero level. Somebody will go to top of Mount Everest and say zero level. Zero level is where you choose it. Is that okay? So you can choose, but you can't change the zero level once you have chosen. And there is a small trick. So this is a problem solving trick or a tip. We won't use it immediately and it's not safe, okay, but you will find that some problems this becomes extremely useful. If there are two objects, let us say I have this ball and this ball. Where should I set the zero level? Should I set for both of them as the ground being zero level? Not required. For this fellow I can set it here. For this fellow I can set it there. They can have different zero levels. But as they move around, For this fellow, you must always count it from its zero level. For this fellow, always from its zero level. The trick is each object can have its own zero level. But keep in mind, in the beginning of the question, if you said this is zero level for this fellow, throughout the question it may go up and down, that zero level cannot be changed. This is not safe. It's a nice shortcut. That is safe. Select one zero level for everybody is safe. In schools, mostly they'll expect that that's what you will do. In fact, many people think this is wrong, but it's not wrong. You can select for each object its own zero level. Okay, right. So I hope you know how to calculate potential energy. So if I drop an object, at that point it has kinetic energy 0. It has some potential energy, because right now let me say this was the zero level. If I make this the zero level, and let's say this was 4 meters, mass of let us say 2 kg, then potential energy will be, initial potential energy will be how much? 4 is the height, mass is 2, g is 10 into 4. Should I say plus 4? Should I say minus 4? It is height above. This is my zero level, height above. So therefore plus 4. So potential energy when it was there is 2 into 10 into 4, which is 80 joules. When this fellow comes here, its potential energy has become 0, because height above zero level is 0. So potential energy has become 0. But it gets a kinetic energy. We will study this more carefully. But how much kinetic energy does it get? It will get exactly this kinetic energy. If I had given it kinetic energy in the beginning and it went up and it came back, when it went up and stopped, kinetic energy became 0. But whatever kinetic energy started with became potential energy, and whatever potential energy it now has become kinetic energy. We call this the fact that energy can get transformed from one form to the other. That's just a way of saying it. Really what we know is that potential energy is one way in which gravity stores the work or the energy that was supplied to the object. It takes it and stores it as mgh.